Hello, you guys hear me? In the back? Yeah. Good evening. My name is Kasra. Nice to meet you guys. Special shout out to my friends that came out to support. You guys are pretty awesome. So the topic of today's talk is autonomous websites. I was thinking we also beforehand, I'm like, how should I start? You get a little bit nervous when you're talking to an audience, and I'm like, just introduce yourself. Get to the material. So my name is Kasra. I work at Deloitte, and I'm part of Deloitte Digital. So what we do is we build websites and applications essentially for clients. And just machine learning and AI has been something that I've been really interested in, and it's been my passion. I have a pretty long commute home, so I get to study it day after day, and can't complain about it. So the topic today is autonomous websites. So the idea is, how can you make websites that can learn from user behavior over time and kind of adapt themselves, right? So rather than putting conditions in there and building it with your own intentions, you allow the website to learn over time and adapt. So let's jump right into it. It's just like I described. So in order to do that, you basically need an intersection of two things, right? You need the intersection of website development as well as machine learning. And that's what we're going to talk about today. So just a show of hands, how many of you guys are website developers? Front and back. Okay, majority of you guys. And how many of you guys have familiarity with machine learning, its libraries, what it does? A fair bit of you. So I was thinking maybe I can spend 5 minutes going over kind of the building blocks of machine learning, mainly because it's just something I'm really interested in and love to talk about, and I thought some of you could get some potentially advantage out of it. For the data scientists in the crowd, please feel free to kind of jump in and provide your input as well. Okay, so what is machine learning? Does anybody want to help us understand what machine learning is? You could also just read that. So, machine learning is about teaching the computer to kind of recognize patterns in the data and come up with its own solutions rather than us programming in groups, right? So instead of having if statements, if this, do that, you just give the computer raw data and you tell it, okay, you learn yourself, you come up with those conditions, right? That's a very simple terminology. So I was going to spend 5 minutes and talk about the building blocks of machine learning, right? I think this will go a long way, and it will help us kind of understand the topic a little more. So if I were to break down machine learning, I would say it kind of boils down to 4 things. One is linear classifiers, and I'll go deeper into each of these. One is classification, one is clustering, and one is reinforcement learning. And the first two are what is regarded as So linear classification, right? What is that all about? So essentially, let's say you have a set of data for which you have X and Y, and you can fit a line of best fit through them, right? This is something we all learned in high school, nothing complicated, right? So machine learning can actually do that for you, but the beauty of it is, this is something you can do in Excel, but machine learning gives you the same ability in multi-dimensional space, right? So imagine now you have 200 inputs and 20 outputs, right? That's a more complicated problem. So as an example, for input, you have the square footage of a house, and the number of bathrooms, the number of rooms, and the output is the price of the house, right? If you give it a bunch of examples, it can learn the relationship between these data sets, and once you give it a new house, you don't know the price, but you know those 3 input parameters, it can generate or predict an output for you. Okay, so far so good? And yeah, again, the beauty is it does it not only in multi-dimensional space, it also, the algorithms are designed to do it really, really quickly, right? As quickly as possible. So this is something that will take a long time. Second thing that machine learning can do for you is classification, right? So let's say we have a bunch of inputs, and that translates into a certain output, not necessarily a number, like a linear classifier, but some sort of a discrete output, right? So let's say the input could be the square footage, the number of bedrooms, and the number of bathrooms, and the output could be, is this a detached home, a semi-detached home, or a condo, right? Rather than a price, which is a linear output. And machine learning does that by kind of creating these boundaries, as you can see here. And when it sees a new data point, it says, okay, which boundary does this data point fall into? And then that's the kind of output that it predicts, right? And as you can see here, there's sometimes overlap between the boundaries. Like you see some blue dots here and some green dots here. So that's the nature of data. It's not perfect. There's always data leaking over. But the beauty of this is it can also give you a confidence of the data, which classification it belongs to. So if I have a data that's kind of in the middle here, maybe the machine learning algorithm says, hey, I think it's blue, and I'm pretty confident, like 100% confidence it's blue. But when it gets towards the edge, it says, okay, I think it's blue, but I'm confident like 55%. So you can get those probabilities out of the machine learning algorithm. So something unique about the last example, linear classifier and classifications, they both are mapping an input to an output, right? And again, the same here as the linear classification, your input could be in multi-dimensional space, right? It doesn't have to be x and y. That's its power. So the fact that you have input and you have output and you're binding them together, that's called supervised learning. So it's learning based on inputs and outputs. Now, clustering is kind of a different beast. So in clustering, you don't really have outputs. You just have a bunch of data sets, right? You say, okay, these are the behavior of my customers based on a bunch of inputs. And then you ask the computer to kind of cluster these data into different sets, right? So it finds kind of different segmentations in your data. This is something you don't provide an output to it. It's called unsupervised learning. So let's go for an example like market segmentation, right? You have the behavior of your customer, you can kind of segment your market based on something. So reinforcement learning is actually really fascinating. In reinforcement learning, it's very different. You don't really tie inputs and outputs together anymore. All you're doing is you're setting up an environment where the computer can take certain actions, right? For example, in this game, the computer can go left or right. Those are the actions it can take, right? And then you define this environment, and you also define rewards for the computer. So in this case, the reward could be the score that you get, right? And the reward could be positive as well as negative. So you can say if you lose, that's a negative reward. If you score, that's a positive reward. So you just set up this environment and this reward system, and you just allow the computer to run. So it starts taking random actions, just random actions, right? Going left, going right a little bit, observing where the ball is, where the score is. And over time, it actually starts to understand the environment, and it starts to behave in a way to optimize or maximize the reward that it's getting. So people have done this very successfully with Atari games because it's a very, very simple environment, and it has proved to perform in the superhuman level once it's trained. Granted, it does take a couple of days for it to train, but when it does, it's amazing what you can get out of it. Any questions? Sure. Just cover what clustering was?
Yeah.
So clustering is, imagine you have a bunch of data, and you want to understand what data points are closer together or are similar to each other. So it will find kind of areas or clusters where the data is similar to each other. So it says, I think these type of customers belong to this kind of group. It doesn't provide characteristics of those groups. It just says these customers are alike in these 5 different groups. Okay, So just one more note here before we move on. So you might have heard of neural networks. I just wanted to kind of double set for what that is. So all of the things that I mentioned right now, for the most part, could be done with statistical models or could be done with neural networks, and they're different approaches. Statistical models are based in math. They're mathematical models that have been perfected over time. Actually, decades and decades of work goes into these mathematical models that are freely available to us, and just in one line of code you can get access to it. It's pretty incredible. Or you can use neural networks, right? Neural networks are kind of a different beast. They do kind of the same stuff. They do linear regression and classification and things like that, but the approach is completely different. Neural networks, to put it in a simple term, it kind of represents or tries to mimic what a human brain looks like or acts like. So the way we understand human brain is just a collection of different neurons connected to each other, firing these things. Right? And then that's kind of what we're trying to mimic in the computer, right? We're creating these electrical nodes that are connected together, and to simply put it, we show it as input, and it kind of creates these nodes in the middle line up, right? In some sort of a fashion or an order, and we tie that to a certain output, right? So imagine you show a picture of a cat, and there's some sort of lighting up going on, and you tell them, hey, this is a cat. And next time you show it a dog, you say this is not a cat. You show it a bird, you say this is not a cat. And then you show it a cat again, you say this is a cat, right? So it kind of starts learning by understanding these connections and how the flow of electricity works. Just put it in a very simple. And then this is kind of where a lot of breakthroughs have been happening over the past 5 to 10 years. This is where we've made a lot of advancement in terms of understanding speech, understanding images, trying to understand more of the things that humans can do can be replicated in computer because of the physics. Okay. So Python. Python is the language of choice when it comes to data science, and there are good reasons for that. One is it's very easy to manipulate data in it. So you can think of it as Excel on steroids. Python itself is not, but it has a library called Pandas, as I mentioned, that's amazing at manipulating data. It's also at the cutting edge of AI, machine learning, and neural networks. And again, there's libraries that pretty much provide you all the things that you want to do is already made. You just bring it in and you call it, and it does that. So for those of you that are interested, AI and machine learning, a lot of the statistical models are done in a library called Science Kids Learn. That's very intuitive to use and to learn. And a lot of the neural networks are done with, so Google has TensorFlow, there's PyCharm, there's a library called Keras that builds on top of these things and makes it a lot easier to work with, in case you're interested. And another advantage of Python is that it can be hosted on a server. Right? So if you're an R fan, R is great, but Python can actually be the backend of a website, which is really powerful. Granted, Python is not the fastest language. If you need high frequency stuff, then you might want to go with C or Go. Okay, so we're actually going to do a little bit of a demo to kind of get into what I mean by autonomous websites. This is kind of the meat of the talk. So if I could get everybody to go to that URL, and I'm going to do the same thing on my website.
Steal all our data, right?
Sorry?
Now you steal all our data, right?
Yeah. Is it showing up? I hope it does. There goes my phone. Do you guys see like an empty graph? Gotcha. Okay, let me generate it. I think it's like a short term. right, try this one. You see it? Short URL.at/is. Is it showing up? Yeah?
Yeah.
Everybody good? Move on. Okay, so I'm going to get you guys to click on one of those buttons that you see. I'm kind of like that. We see the results here. Right?
Can we click more than once?
You can, so you have to stop at some point. Wow. You stop clicking, guys. Okay, that's cool.
Are you sure this is manual and you're not pulling our URL?
Alright.
Still trying to get the URL.
Oh, sure. So, one thing you guys will see is that kind of both of us have been shown this pattern, right? With green, with light blue, and navy, right? So, what you're seeing here is the kind of how the mobile clicks have what pattern they've shown over time, right? So if I click on my desktop here, I can't even show it because you guys click so much. Nothing shows up. So you can see like the light blue coming up a little bit on my end, maybe coming up a little bit. I'm still clicking. And then I guess. All right. So as you can see, when I'm clicking on my desktop, it shows up on the right. Like if you pull out your desktop and click, you see it shows up on the right as well. But the mobile data shows up on the left. So we can see a lot of people use our site on mobile. Maybe we should just go with only mobile. Okay. So what I have here is a button called train. Thank God I didn't put that on for mobile. Thank God that only exists on desktop. Right? So what you can see is that this order that is shown here seems to be optimized for both mobile and desktop right now, right? It seems that green is the preferred choice, then navy, and then light blue, right? So I'm going to try to change things up on my end. Driving at my green. Alright, so I'm clicking on something as fast as I can. Alright, so we can see a clear pattern here, right? On the desktop, people seem to prefer light blue, but on mobile, people seem to prefer green, right? Wouldn't it be great if we could modify our site so that preference is shown? So I'm going to do a train. Hopefully it won't break. I've never trained it with that many number of clicks. We'll see. So I'm going to refresh my site, and then I want you guys to refresh at the same time. So I refresh. So you can see that my desktop is now showing me different orders, right? Based on the preference that the machine sees on the desktop platform. What do you guys see on your site?
Electronics.
Sorry?
Electronics. I see green for sure.
Sweet. I know people are messing around with it as we're talking
I'm
about.
messing around with it.
Yeah.
I've been messing with green and I get green number one.
That's great. That's good stuff.
That's not
Middle. So if I train now, remember this pattern right now. I'm going to hit train. You guys can refresh now. You should see navy, then green, then light blue. Yes? All right, good stuff. Okay, I'm going to take this website away. Okay, so what did we see there, right? we saw a website kind of adapting itself to users based on whether they're on mobile or desktop, right? So we have a simple segmentation between users. Obviously, this is not something new, right? You see this every day on Amazon, on Netflix, right? They have recommendation engines that they optimize what you see based on the behavior of yourself and other users, right? But one key takeaway that I want you to have from this meeting is that, yes, they do have those things and they spend millions of dollars to build those recommendation engines. But you don't need $1 million to create something like that for your website, right? You can create these optimization algorithms for free, and they're very simple to make, right? And you can custom make your website based on what the users are telling you that they like. So I'm going to walk through a little bit on what this slide was doing, and then I'll explain a little bit about how we make it. So there's a database and there's a React front end that you can click on, and you can see the results. There is also a Python backend here that you can actually, in Python, it's kind of like Node. You can make endpoints and you can run functions, right? Whereas in Node you need something called Express to kind of export ports and APIs. In Python you can use something called Flask or Django to do that. So you kind of expose these endpoints on Python, these APIs, that one of them in this case says train and one of them says predict. So every time I click on that train button here, my Python train button gets called. It gets the data from the database, it dumps it into a classification algorithm, right? And basically that classification algorithm learns based on an input of mobile or desktop what it predicts the user will click on, right? And the beauty of it is I can get a percentage for each of those buttons. I can say, what do you think is the probability that the user on mobile will click on blue? It gives me a percentage, and the rest will be other ones. And then I can make the order of the buttons based on the highest probability of what you're going to click on to the lowest. Make sense? And whereas here we did a very simple example of mobile versus desktop, this is something that we can absolutely expand upon, right? You can do it based on location or demographics or whatnot. And it could be used on an order of a list or the style of your website or whatever, right? The possibilities are endless. The idea here is that you can learn from your inputs or users and kind of map that to an output of different kinds of output that you can design. Okay, a couple more slides. So, A/B testing. How many people are familiar with A/B testing? Okay, does anybody want to tell us what A/B testing is? Students? Yes.
Presenting two versions of your website in order to understand how most differences affect behavior.
Exactly. Yeah. So you kind of make two versions of your website. You make them available to the public, and you gather insights as to how people are using it, and you have a target, right? And you're like, which one of them helped me achieve my target better? To give you an example, so I'm at Lovelock's right now, and on one of their checkouts, they're doing A/B testing to see which one of them has a better conversion at the end. And you can imagine like a 2% higher conversion for a company like Lovelock is millions of dollars, right? But what typically is done in the industry is they do A/B testing for two separate versions of the sites, and at the end, one of them performs better, they're like, okay, perfect, we'll keep A, right? We'll disregard B.
Depends on the p-value.
So depending on the p-value, they either choose or drop one of them, right? So simple enough. So the idea is that you can actually do that, but what if some people are more prone to A, they do better on A, and some people do better on B, right? What if there could be a middle ground where you could understand which customers will perform better on A and kind of send them to that flow, and understand which customers are going to perform better on B and send them to that flow, right? So there is still advantages to be had. Maybe it's not A or B, maybe it's which time A to which customers B. And if that's going to allow us to increase conversion by even 1 or 2 more %, That's the huge value add to the business. All right. So, as the last piece of, I guess, this presentation, what if you could use reinforcement learning to design a website? Right? That's something that I haven't come across. If you have, please let me know. But it's really fascinating stuff. So the idea is that you can design a website where you can tell the algorithm what parameters it can play with, right? Whether it's the style, you set up a certain style, you can set up the order of things, you can set up the text or whatnot, right? And each time the computer or the algorithm shows a website to a client, it would make some minor random modifications to the site based on the environment that you set up for it, right? And then at the end, you also have a reward system attached to that. So you say, this is what I care about, right? At the end, I care about user conversion, or I care about user staying on the site. These are the parameters I care about. If they leave the site, that's negative reward, right? And you allow the computer to show this site to millions of users and kind of come up with its own version of what really the site should look like to maximize those reward systems that you have put in place. So you create the environment, you tell the website what it can do, and you tell the website what you want to accomplish out of this, and then the website kind of builds itself using one random iteration at a time, and it kind of maps these randomnesses over time to understand which components added together provides the best output for you. You'll probably see that in a few years. I'll tell you that. Right? Thank you guys.
So all of this assumes that your website is autonomous. And at this point, when we do A/B testing, we're looking at the hit rates of our, basically how well they performed in our sales funnels to decide whether A or B was better. And it's just pure numerical. And then we make a decision in a board meeting, and we decide to go with B. But you're saying that let the website decide and let the website go ahead and do that. And that's an extra layer of programming, which we don't have that luxury right now.
Yeah. So I guess one thing that I really wanted to show today is that one, having that extra layer is a lot simpler than you might think. I wish I had the code pulled up. Like the React is like a few files and like lines of code, and the machine learning file is just 50 lines. Nothing compared to the React. So first of all, it's not hard. Is the one thing that I wanted to mention. And the other one is, so this could be, if we have this layer, it could be as a third kind of a thing that we test, right? We test A, we have a conversion. We have B, we have a conversion. What if we test A and B together with this layer which decides which one to show and what is the conversion or the output of that? And if that one's the higher one, maybe that's the right direction. Answer your question? Yep.
Do you have any thoughts on generative models? Like, even a set of parameters for, say, for the user, and you can, like, based on the randomness, generate a set of things that you don't like, and set that you want to kind of think of.
Yeah, absolutely. So I think this will really take off, the reinforcement learning part, when that generative versus discriminative models can actually produce things that are indistinguishable by humans. Just to provide some context in case you don't know, it's really fascinating. So there are models that are based on, the model just kind of generates some random, let's say, picture, and then there is a discriminator who is trained on, for example, what a flower should look like, right? There's a model that can say, yes, this is a flower, or no, this is not a flower. And the generative will just randomly generate something, gives the output to this discriminator, and the discriminator will say yes or no. Yes, this is a flower, or no, this is not a flower. So what's really fascinating is after millions of iterations, this random generator can produce images that actually look like a flower. It's just on its own, right? Based on pure randomness. But humans can kind of tell still there's something iffy about that flower. But when the time comes when you can't distinguish between a generated flower or a picture taken on a street, then I think that's an additional layer that can be attached to this, right? You can generate graphics and put it on your website and see how users are receiving it. And then if they're not receiving it well, you can generate a new one. So I think that's the next step. Once we have that, it's kind of yeah.
Saying that we were being I don't know what called crazy. What
You were doing it, mentioned. You were one of those.
What happened if that doesn't fall? How do you cure that data?
Very interesting. You might have to have some protection layers there to be able to detect it. Maybe a machine learning algorithm that's yes, this is a problem, this is not a problem. It's just legitimate concerns.
So this is actually a big topic in the security world, ML, hacking ML.
Very interesting. That's actually really interesting.
So this looks good, but how do we make money out of it? There are affiliate programs where people sell to each other cookies of users. If you can sell the cookie of an A/B testing like that to a machine learning algorithm of a website, would that make sense?
No,
Why not?
because you can't pass cookies from website to website.
Yeah, well, not literally, but the
What
data from
you're
the
passing
cookie.
is information about that person.
Exactly.
Yeah.
So what you're saying is using it on an individual website. What if you collect the data for a particular user and sell it to other websites?
They're already doing that.
Yeah, but not with machine learning.
Since 1999, we've been doing that.
Not with machine learning though.
It's not machine learning, it's just selling people's personal data.
Not with GDPR now though.
This guy likes big ones. Okay, that's marketable. You can sell that.
So, I guess to answer the question of how we can make money with this, if you can optimize your website to accomplish a certain goal, that goal usually is related to money, right? So if it's conversion, and if you can bump conversion by 1%, for a company like a big corporation, that's a lot of money, right? For data stuff, there's all this gazillions of dollars in collecting this data.
Yeah, but that's thinking only for one website, the one that you own, the one that you build this algorithm for. And once you know the preference, can't you just automate the affiliate link?
Talk to me. I'm doing it.
Actually, yeah.
So this would be an economy of features, if you think about it. All users have a certain bunch of features, and as a collector of data, say via advertising cookies attached to your website, I can collect features about users, and now that's the commodity that I'm selling. I can enrich your model by adding features to it.
Absolutely.
It becomes more valuable, especially when you consolidate all those profile pieces together.
Absolutely. You can get demographic information without having users sign in and provide that information. Absolutely.
To put this into a real life example, Walmart predicted pregnant women before the women knew they were pregnant.
Yeah, exactly.